Magandang araw, ako si Kuya Code. Welcome back to my channel where I teach Python through programming challenges on HackerRank. Today we'll be introducing exceptions, but before I get into the code, I want to introduce two concepts. The first one is something called look before you leap. With look before you leap, this is generally a concept where you check everything before you do an operation with using lots of if statements. It is more common with C type languages like Java, C, and C++. But with Python, it can make code unnecessarily verbose and slow. So instead with Python, it's more common to use something called easier to ask for forgiveness than permission. So with this, you assume that things will work correctly and only handle errors if they occur. So we use something called normally it's in other languages called a try catch block, but in Python it's try except to check for conditions beforehand. So this is generally more common with Python. So as you've seen from the previous section, we have our class here. There are a few issues with it. These are the print statement or the different operations that we have. These would cause issues. So the first one, as you can see, well, firstly, if you run this, it's just going to cause an error like right away. So let's just go line by line. This first line, it doesn't make any sense to have a negative number when you're depositing. So that doesn't cause the program to crash. It'll subtract from the balance instead of adding to the balance, and then this does the opposite. These are both wrong, but won't cause an error. And for this third one, this is what the error showed here. The less than or equal to symbol is not supported between string and int. So because this is a string, what it means is that amount is a string and you're comparing the amount string with the integer, so that is what's causing the error. And as you can see, it actually says the type of error. This is a type error because it's just not the right type. And then this one is called a value error because it doesn't actually cause the program to crash. It's just that it's not the right value that we would want. So there is an exception for that as well. And then this one is a special one that I'm going to be introducing later because we can actually make custom exceptions, which is super useful. And then when it comes to the interest, you got the balance times it by the rate divided by the number of months. But if the interest is passed in as 0, which I can actually just do this, uh, the error is zero division error because obviously you can't pass in 0 for the number of months because you can't divide by 0. So that is basically all of the errors, but we're going to go ahead and start adding some exceptions in order to make this all work. That way the program doesn't end up crashing. So the first two are pretty simple. We can just make a check, which we already have some. Like I said, this one will print out the statement if this is true, but it'll still just go into this either way. So that's not what we want. So first thing is first is we need to get a try except block. So I'm going to go ahead and do try, which we have that, and then except. So this is our try except block. So if there's anything inside of the try block that'll cause a potential error or an issue, it'll automatically go into the except. For this one, because this one doesn't actually cause it to crash, we have to specifically have a keyword that will push it down to the except section. So if the amount is less than or equal to 0, in this case where we have a negative number, rather than doing it like this, we're going to instead do the keyword is called raise. So we'll raise the exception. And what type of exception is it? Well, it's a value error. So now we have value error, and then this is the text that we have for the error itself. But now we have to catch the error. As an example with Java, instead of raise, it's called throw, and then instead of accept, it's called catch. So it's kind of like this one is the one that's throwing it, and then this one is catching it. So that's kind of the idea between these two. So raise is passing it to the accept block, but we actually have to put the type of error that we're expecting or potentially expecting inside of here. And then we can do as e. This is just a variable that's going to grab the exception, and then inside of here we can just print out error, and then just print out e. So now this doesn't actually print out, but it'll print out when we get in here. And actually, I'll just put another thing here just to kind of show. I guess I don't really need to. You'll see it in a second. So let me go ahead and uncomment comment these out. So we're only dealing with the first one. If you go ahead and, well, yeah, let me just do this. So now it's still printing out the same thing where deposit amount must be positive, but now it's printing out error because it's calling it from the accept block instead of just having a generic print statement up here. So that is good for the first value error. And now we can just simply do the same thing for the withdraw. So of course we do try, and then we can do accept, we do value error as E, and then print error E. Okay, and then we also, I think that is also fine where oh, you have to do the raise value error raise. So now if the amount is greater than the balance, then we will have insufficient funds because that would generally bring us in the negative. So that is good for the value error. And now notice though that I can just type, I mean, the program's still going to run even though these errors are being called. So I can just type in hello or something. Actually, we'll just print out something that makes more sense in this case. Balance dot balance. And then we will run this. So even though it looks like that one actually, I might have missed something here. Let's actually take a look. Where did I miss that? Because it has to do with this. The amount, if the amount is greater than, oh wait, this is not the right one. I still need to do a different one for that. I still need to do the same thing. This equals that. Because that, the amount where the amount is greater than the balance, that's a separate check we're doing to make sure it doesn't go into the negative. This one is one that we're doing just to check if it's positive. So I'll have this back for a new statement afterwards, but we'll just put this here for now just so we can see. So now if we were to go ahead and run that again, yeah, so now we do have both errors. The balance is still the same. No withdrawals were made, no deposits were made. So that is exactly what we're expecting. And the errors were printed out. So then for this next one, this one is just, we could probably just do the same thing for withdraw. Just to check. So for this case, as you've seen in the other example previously where it showed as type error, that is a different type of error that we can have. So rather than having a value error, there's another one called type error. We'll put those for here as well, for this one. For this one, we can use the same case for this. So now for the actual try catch or the try block, how do we check if this is basically not a string and it's actually a number? Well, what we can do is if not, there's a keyword called is instance, and then we type in the value. Actually, let me just check something. If it does it show, right, so object, class, or tuple, and then, yeah, returns whether an object is an instance of a class or a subclass thereof. So the first option is the amount. The second option, we can actually just put in a tuple because we have two options. There's an int, which is fine. But also, if you put in a float with a decimal, that's also fine. That's why we're putting in a tuple and not just like a class. So like if you have your own custom class, you could put this in here as well. But when it says tuple, what that just means is that it'll give you multiple options. So it'll check if this first object is an instance of any of the other ones inside of here. So like I said, we have int and then we have float. So it'll check if the amount is an int or a float. If it's not, like in the case where we have a string, then it'll go into the to the next line. So if it's not an int or a float, then we can raise the type error, which will just say deposit amount must be a number. I'll just copy this because it's going to be the same thing for the withdraw. And then we already have the type error in here, so let's go ahead and run this and see what we get. Right, so again, it didn't crash. The program is still working perfectly fine because this is, you know, the very last thing that we have. And it just says, well, I guess this is supposed to be withdraw here, but it's still the same either way. It actually just shows the error message instead of crashing. Let me go ahead and put, just for the sake of it, withdraw must be a number. Okay, so that's it for that one. And then what is the next one here? Okay, this one is a special one because, well, actually, before we do that, we're going to do one more thing. Instead of having a single object like that, what we can do instead is make it like this: accounts we'll have a list of 3 of them. So there's 1, and then there's 2, and then there's 3. So now we have 3 of them. And then what we're going to do instead is we're going to ask the user to type in a index for the account that they want, and then we will just see what happens actually. So what we'll do is account index, or you could also have some more, you know, detailed setup where you actually type in an account number if you want, then it like maybe like searches a list to try to find the exact account number you're looking for. But in this case, just for the sake of having it more simple, we can just type in the index. So int input and then select an account index, and then we'll just put, because we only have 3 options, it's only index 0 to 2, so we'll just put that there as well. And then that's like that. So this is going to be the account index, and then we can just do selected account instead equals accounts at account index. So that would still work. It's just that it's going to ask us for an index instead. This was never closed. So if we'll go ahead and press 0, that's the first one. It works perfectly fine. And then if we were to do it again, index 1, it still works, except this account starts with 500. And of course, if we type in 2, it does the same thing. It worked with 1,000. But here's the problem. If we type in an index that's, you know, past what we have, let's say, you know, 7, it's going to crash because it's an index error, and then it just simply says list index out of range because it's out of range. So this, again, gives us a clue. Let's copy this, and then we can just surround that with a try catch block. So this will be here, and then we'll have the number, and then inside the try, we will do this, and then inside the accept index error as E, and then we'll just simply print error E. And we'll actually just we'll just do while true, just so you can kind of see that the program still runs. Semicolon, or put a colon there. So now it's asking us for a thing or a number here. This one doesn't exist, the program doesn't crash, and because we have it in a while loop, it's just going to keep on asking us forever, and we have another chance. Again, we put in 2, it works. We'll put in 1, it works. We put in 0, it works. And that's a lot better because, like I said, the program doesn't crash. And, it just simply gives you the error message here instead of crashing. So that's definitely way better. So we'll just keep that there for now. So now we'll get on to what I mentioned before with this one. So with a lot of banks, there's something called overdraft protection, where it allows you to go in the negative, but only a certain amount. So it's not the same thing as this, because this is just depositing, which is adding money when it's a negative number, mean taking it away. But if you were to keep on withdrawing and withdrawing and withdrawing, in the current setup, it'll just keep on going farther and farther into the negative, basically to as much memory as you have, like millions and millions. But we're gonna have something that will allow it to go into the negative, but then it won't go into the negative. It won't continue going into the negative when it hits a certain point. So for that, we need to make a new exception. So what we can do is I can just make a new class here. Class, we'll call it overdraft protection because that's normally what it's called. When it's associated with banks. Overdraft error, actually. And inside of here, instead of passing in self, we're passing in exception. This is because I'm going to go into more details. It's associated with object-oriented programming. This is a separate class, the exception class, which is basically the root or the parent class of all of these other types of exceptions. So we're basically saying that the overdraft error class that we are creating will have access to all of the regular methods and features within the exception class, but we're basically extending it to add in our own thing. And like I mentioned, I'm going to be going over more details on how this works in a different video, but just know that this is the parent of the overdraft error class. So after that, we can just do def init. We'll just pass in self, and then we'll pass in limit attempted, just so we can print out some details. And then we'll call super. Super just refers to the parent, which is the exception. Init, and then, so just like with this one, the type error, we're passing in a string, which is just a message. But in this case, we're taking the message and we're passing it to the exception class's initiate function. So it's being typed out in the overdraft error class, but it's being passed to the exception class, which is the parent class above it. So we can just do overdraft limit exceeded. Allowed is this amount. Attempted is this amount. So the allowed is the limit, and the attempted amount that you try to take out is just whatever the attempted is. So now that we have our custom exception, we can just grab this, and we can, I guess we'll have to put it inside of here when it comes to withdrawing. So let me go ahead and make a new case here. So for withdraw, we'll make another if statement here. So if self.balance, subtract the amount you're trying to take out, is less than self.overdraft limit, then we'll do something. We will raise. We'll have our custom class here, self.overdraft limit, and then self balance minus amount. And of course we don't have this yet, so we'll go ahead and put this here. Self.overdraft limit equals overdraft limit. Of course, what should the overdraft limit be? What we can do is just put in a default here. So let's just say, you could just leave it at $200, but then it's kind of confusing because this is the amount that you're allowed to go in the negative. So the overdraft limit is, we'll just put a negative $200 value. So you're allowed to go into the negative, but only up to $200. So we'll have that as a negative value, or else it's kind of weird. Just trust me on this. If you have it as a positive value, the calculation for this ends up being weird, and then it's just annoying. So we'll have this as a negative, which definitely makes things a lot cleaner. Of course, don't forget to add it to your accept. We can also put in an extra one here as well. You don't necessarily have just one. We'll have that, and that way we can just print out a custom message. So if you want your message, instead of having this for every single error, if you have a custom one like we have here, then we can just put in a custom message. So this can just be overdraft warning. And then we'll just still have the E. So of course the E is taken from this, so it'll just show that. So let's go ahead and try this. So we'll go ahead and do this. So let's just think here. So we're starting at $100, and if we subtract $300, that'll put us exactly at negative 200, which should be allowed. If you try more than $300, that should trigger the exception. So let's just put this at $300 exactly, just to see what happens. So there we go. We withdrew $300. The new balance is negative 200, and then negative 200, which is exactly what we want. But if we do 301, this should trigger it unless I type something wrong. Yes, I typed something wrong. What is this? Line 28. Line 28. This is a comma. That's supposed to be a period. Try again. So now we get a message instead where it says overdraft warning, overdraft limit exceeded. We're only allowed negative 200, but we tried to go to negative 201. So that is our custom exception message to let us know that we're not allowed to go below 200, which is great. And I guess the last one is the interest one, which is pretty simple. So we'll go ahead and do this. Let's see what we get when we do this. It crashes because you cannot divide by 0. It's called the division or zero division error. And then for this, what we can do is, let's see, where should we put this? Where's our calculate interest one? Here, there it is. So firstly, we'll do our try catch. So we'll try, and then if rate. Let me just see. We'll do if months equals 0. Because in this case, if rate is 0, it's not going to crash because 0 divided by 100 doesn't cause the crash. And, even if this is 0, again, 0 divided by months doesn't cause the crash. It only causes the crash if you somehow leave months, empty or so, I guess you could just, do this. Or actually, it's better to leave that not a default. That way it forces you to type it in. But if months is equal to 0, that's what would normally cause the issue. And then you can just simply raise the, months cannot be 0. We got that. And then we can do this, and then of course we need our accept. I think this needs to be accept zero division error as E, and then print F error E. Move this back a little bit. Do that. And let's go ahead and see what we get. I forgot the colon like usual. 0. And now it says months cannot be 0. But if we change months to a proper value, let's say 12 months, and then try it. Now it says we've earned 17 cents for that month when you do the calculation of, $100, 2% interest rate for 12 months, it's 17 cents for that month. So that is all the exceptions for this section. Everything worked. The program's still running. It just gave us all of our error messages. That's definitely a way better way to do things than having a giant list of if statements, especially because, this, for example, we have a type error. There could be a number of different ways that could cause the type error to trigger, and regardless of what the issue was, it's still going to print it out. Whereas if you have a bunch of if statements, you have to make a new if statement for every single type. So this is more of a catch-all, and if there is no issue, then it just completely skips all this, and then it just runs a lot faster instead of having to do a check regardless. So that's why it's referred to as easier to ask for forgiveness than permission, because you are not doing any check for every single, variable you're trying to calculate or whatever. So that's it for this section. So let's go ahead and go straight into the coding challenge. So before I go into the coding challenge, there's actually one more thing I wanted to add. When it comes to these try except blocks, there is 2 more things that we can actually do as well. So we'll just do it quickly. So there's actually an else statement you can put, like normal if statements. You can also put the else statement for the try except. So let's go ahead and put print statement, and then we can write withdrew amount, new balance, self dot balance. So what this means is that if this has 0 errors, these 2 won't get called, and then it'll just automatically go into this because the transaction was completed. So the else is only called if this has 0 errors. And then the last thing that we can do is call it a finally. So a finally block is something that gets called regardless if there's an error or not. So we'll just print transaction completed. So we'll go ahead and try this. This is a withdraw, so we'll just get rid of this, and we'll just put in a proper value here, 50. So like I said, for this first account, we start with 100. We're gonna withdraw. Well, actually, we'll do -50. This is you get the error, and then it says transaction complete. And I guess you can probably just ignore this too. But then if we do this and put in 50, then what we get is must be a positive number. So that is something I messed up. Let me just see here. Self is less than the balance. Oh yeah, that is not correct. This is supposed to be 0. Less than 0. Let's do it again. So now what it shows is it withdrew the amount, and then the new balance is 50, and then it says transaction complete. I suppose because this is going to happen no matter what, this doesn't really have to be here. Right, withdrew 50, New balance is 50, transaction completed, and then we're good to go. So compared to this, the challenge is kind of easy. It's pretty, trivial. There's only a couple inputs. The first input is just the number of inputs. So that is just simply tests equals input or int input and then for underscore in range t. Oh, and this is kind of obvious, but when you go to Python, there's a category called errors and exceptions, and this one is just called exceptions. And it's going to give us a number of inputs, and we just have to check, if it's correct or not. So, for example, the first one is a 0, which is fine. The second one is a $sign, which is bad, because it's supposed to be all numbers here, as you'll see. And then the third one is going to be, is that that looks like a 1. Sometimes it's hard to tell if it's a 1 or an L, but those are basically what the inputs are. So, oh, this is the sample. This is the sample output. This is an error that has division by 0. So that's for this first one. The second one is you're not allowed to use a $sign. And then the third one, this is just a 1. So the third one is actually okay. That's why it's going to print out 3 like normal. So for this first one, we're going to do is, of course, we need our try catch block like usual. And then there's 2 values here. There's what's called A and B. And then we will try to map it to an integer. So if we have a number, like this is not an integer, so this is going to fail on the second option. And then we can just print A divided by B, which this will catch the first option because you can't divide by 0. But if you do 1 divided by 3, this would work. And then because they're both integers, they're both able to be converted to an integer, this one would work as well. So we'll just make our accept blocks now. I guess we don't really need that. 0 division error SE, and then print error code, comma E. I'll just copy and paste that. This one will be the value error. And that should be good. So let's go ahead and run this. So that is exactly what we wanted. And we'll go ahead and submit. And looks like we're good to go. So that's the end of this video. Please like and subscribe if you found this video helpful for more coding challenges. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.